In this video, we will learn how to determine whether a quadrilateral is a cyclic quadrilateral. First of all, let's take a look at this case. Suppose I have 4 points here. If I can draw a circle such that it passes through all the 4 points, then we will say that A, B, C, D are concyclic. So concyclic means lying on the same circle. On the other hand, if we have 4 points and we cannot draw a circle to pass through all the 4 points, then we will say that these 4 points are not concyclic. Same here, if we cannot draw a circle to pass through these 4 points PQRS, then we will say that PQRS are not concyclic. If 4 points are concyclic, that means if we joined A, B, C, and D, we can form a cyclic quadrilateral. That means if A, B, C, D are concyclic, it is equivalent to say that A, B, C, D is a cyclic quadrilateral. In the last video, we have learned that when we have a cyclic quadrilateral, then the sum of the opposite angles must be 180 degrees, and the reason is opposite angles cyclic quad. Now let's consider the opposite case. Suppose we have a quadrilateral and we want to know whether it is a cyclic quadrilateral. If it is given that the sum of the opposite angles is 180 degrees, then we can actually conclude that the points A, B, C, D are concyclic. That means A, B, C, D is a cyclic quadrilateral. And the reason is opposite angles supplementary. Supplementary means the sum is 180 degrees. Of course, this property is still true for the other pair of opposite angles A and C. If the sum of angle A and angle C is given to be 180 degrees, then we can still conclude that A, B, C, D are concyclic, and the reason is the same, opposite angles supplementary. Now let's take a look at the proof of this property. Suppose it is given that angle ADC plus angle ABC is 180 degrees, and now we need to prove that ABCD is a cyclic quadrilateral. In order to prove this, first of all, we may assume that ABCD are not concyclic. Here it is assumed that D is inside the circle. There is another case in which D can be outside the circle, but the proof is similar, so we just take a look at this case only. Now we can produce CD to meet the circle at E, so that ABCE is a cyclic quadrilateral. According to this diagram, angle ADC must be greater than angle AEC, because angle ADC is an exterior angle of triangle AED. That means based on this construction, this angle ADC must be greater than angle AEC. On the other hand, we know that it is given that angle ADC plus ABC is 180 degrees, and furthermore, based on the property of cyclic quadrilateral, we can conclude that angle AEC plus angle ABC is 180 degrees. Now, based on these two equations, we can conclude that angle ADC is equal to angle AEC. However, there is a contradiction here, because these two statements cannot be true at the same time. Since there is a contradiction, there must be something wrong in our assumption. That means we can conclude that ABCD are actually concyclic. That's why if the two opposite angles are given to be supplementary, this quadrilateral must be a cyclic quadrilateral. Now let's take a look at another case. In the last video, we have learned the property of exterior angles of a cyclic quadrilateral. Suppose now we do not know whether this is a cyclic quadrilateral or not, but we are given that angle ADE is equal to angle B. Based on this given information, we can actually conclude that ABCD are concyclic, and the reason is exterior angle equals interior opposite angle. The proof of this property is similar to the previous one, so I'm going to skip this. Finally, let's take a look at this case. In this diagram, we do not know whether ABCD are concyclic or not, but we are given that angle A is equal to angle B. Now, based on this given condition, we can conclude that ABCD are actually concyclic, and the reason is converse of angles in the same segment. Again, the proof of this property is similar to the previous one, so I'm going to skip this as well. To conclude, in this video, we have learned 3 ways to show that a quadrilateral is a cyclic quadrilateral. These are converse of angles in the same segment, opposite angle supplementary, and exterior angle equals interior opposite angle.